I'm Bruno Fierens. I'm the CEO of TMS Software. We are based in Belgium with the main team and have several developers all around the world. And so this session is about TMS Web Core, and we're going to have a look in how we can use the technology of TMS Web Core to create applications with Object Pascal that run everywhere. So I'm going to show you some samples, but first of all, I wanted to have an idea how many of you have heard of Web Core before, and more exactly who have used Web Core before. Who has used it before? I see one hand. Okay, that's a good indication at what level I better start with this presentation. So, first of all, big question, what is TMS Web Core? And this summarizes a little bit what it is all about. It is all about creating web client applications. That means these are applications that run in the browser. This is different from a web application framework like IntraWeb or UniGUI, which create server applications. The application runs on the server and sends HTML, JavaScript to the browser as the application executes, while TMS Web Core is a technology that creates a web client application, and so this application is downloaded the first time you hit the URL where this application is, and then starts executing in the browser. And even in theory, it does not need the server anymore after the point of having downloaded and started that web application running in the browser. The methodology that we are using for creating such a web client application is, of course, Object Pascal based, object oriented, RED component based application development. This is also typically, this architecture is typically referred to as a single page application. So that does absolutely not mean that there is only one page in this application. No, that rather means that the application is started from a single URL. And that while you are using that application to show form 1, form 2, and many more forms, the application basically still always runs from the same URL. So there is the name single page application coming from. I did not invent that name, but it's the same name of or type of application that, for example, an Angular or a Vue or a React application is. One thing that is important in creating such a web application, knowing that it will run in a browser and that the browser is ultimately responsible for rendering your application in the browser, is a difference between how we will design the forms. So either we will, or you can, use the classic VCL approach where controls are absolutely positioned on the form, and your controls will look like you designed them on the form designer when your web application is running. As opposed to letting, via HTML and CSS, let the browser do the work with HTML and CSS to create the flow of your layout in the browser. Both techniques are possible from TMS Web Core, and it's actually up to your free choice what kind of method you will be using. Web Core creates web client applications. They run as JavaScript in the browser. And that means in the browser, we are in the JavaScript world, and that means that we can also use other existing JavaScript libraries and integrate them, use functionality of these libraries, so it's open to consume everything that exists that is available for web developers via JavaScript as well. FNC UI controls, that is a type of controls that we created so that with one code base we can have user interface controls and other controls with one code base, and they can run in VCL applications, FireMonkey applications, LCL Lazarus applications, but also in web core web client applications. So you can also take advantage of our family of FNC UI controls in your web client applications you create with web core. With respect to deployment, that's also an important one and a frequently asked question. What kind of server do I need to deploy my web application? Well, it cannot get any more simple, because basically what the web core web client application will generate is JavaScript files, and in combination with that you can have HTML, CSS, maybe a couple of images, but that's basically it. That means that any HTTP web server will do to deploy your web client application. So whether it's IIS, Apache, or anything else, you just put these files in a folder on your web server and you are basically up and running. A small anecdote, I still remember there was one customer who had an Arduino board with an Arduino head on it that contained a web server, and he was able to deploy the web core web client application on the head coupled to the Arduino to send some measurements from the Arduino equipment via a web application to any web client that could connect. Then of course there is the question, okay, your web application is running in the browser, and how do we do something, for example, with data that is on a central database on a maybe different server? That is typically done via REST API endpoints. So HTTP requests performed from the web client application to the backend, the server, and that server then communicates with the database to perform whatever database operation that needs to happen. Now, what types of web client applications can we create with web core? First of all, of course, obviously the basic standard web client applications. So anyone who has a browser navigates to the URL, application starts, and you're up and running using this application. But there is more to it. A next step is the ability to create what we call progressive web applications. But that's also not a name that we invented. Progressive web applications is a set of requirements that actually Google is a driving force behind that, a set of requirements. And if your web application meets these requirements, it means that you will be able to install this web client application on the device. That is supported by Android, that is supported by iOS. It is also supported by desktop browsers such as Chrome or the Edge Chromium from Microsoft browser, also Firefox. So, and when your web client application can just run and does not need a backend, that also means that your web client application will be able to run offline. That's also something that goes together hand in hand with the type of application, progressive web applications. And two other ways to create an installable desktop application that can also maybe run offline on a desktop computer is via either the Electron framework or our Miletus framework, which are frameworks that create standalone executables cross-platform. for Mac, Windows, Linux, Raspberry Pi, and you can just take the executable and deploy them on a desktop operating system and run from there. But we'll cover that in more details in this session. So basically, here is a picture that shows you where web applications can bring you. You see, I think, almost any device that currently exists that you maybe also use in your daily life, the smartphone, the tablets, maybe some IoT device like a Raspberry Pi, and of course the desktop operating systems. So from there, your web client application is usable. Here's a diagram that shows you the possibilities for your web application to consume or to do any operations on the backend, on the server, on the database. So WebCore was designed to be open, to work with any database or other server backend and not enforce you to use any specific technology. And so among the more popular choices, but certainly not limited to, are the Embarcadero Red server, for example. It can be a Node.js server. It can be something created with our TMS Xdata technology that allows you to create a server application that exposes API endpoints and that you can call via HTTP requests. And this is then with such a setup, with the front end, the web client application, the back end, the server application. This is how you create what they call the full stack. And that is your web client application runs in the browser and does all the communication with the backend over HTTP requests, where typically you're not forced to, but typically the data format that goes back and forth between the client and the server is in the JSON format. Now, technically, how do we achieve that? For us as Object Pascal developers, everything happens thanks to the magic of the Pass2JS transpiler. So the Pass2JS transpiler is something that is created by the FPC team, and it enables you to compile or transpile Object Pascal code into JavaScript code, and it's the JavaScript code that will run in the browser. And it's on top of this transpiler, the RTL that comes with it, that we created the WebCore framework, integrated that in several IDEs, and from there you create the web client application. And our framework embraces what the modern browser these days exposes. That's certainly a trend in the last, let's say, 10 years, that browsers have continuously improved, enhanced, extended access to your rich environment of your computing device. Where, for example, it's nowadays standard that you take advantage of your device microphone, camera, also local memory. There's even a local database that you can access within the browser context. And for example, very interesting, I think, is that the Chrome desktop browser at this point also supports USB and Bluetooth devices. So if you have USB and Bluetooth devices connected to your machine, the browser is nowadays enabled to access these Bluetooth devices, these USB devices, and you can perform all kinds of communications straight out of the browser. Also something like 3D, so that's under the umbrella of the WebGL API. With the WebGL API, you are able to perform or create 3D rendered scenes directly from the browser. It's the browser that's responsible for doing everything needed with your graphics card, acceleration, etc., to render these 3D things. So that's, I keep it to that as an introduction. I think you will most likely be more interested in seeing everything working. So let's have a look at some examples. And for these examples, I will be using the Delphi IDE in this case. So here is our Delphi IDE. WebCore is installed, and under Tools Options, that means that there is a new entry here, a new entry available from where you can configure various WebCore options. Normally, upon install, all these options are set to, and my screen goes black here. Is it back? Okay. So normally all these settings out of the box are right to let you build web applications, which you can start from the file New and Other, where you find a new tab, TMS Web, and you can see here various web application types that you can create from WebCore. So let's now first create a basic example. And so upon selecting this standard web application, what you can see is the form designer for our main form of the application. And you see in the project manager the web project. Some things remarkable, different from a standard VCL or a FireMonkey application, is where you can see here a project HTML file. And that is actually the HTML file that will be responsible for launching your web client application. So actually, when you launch the application, you navigate to this project HTML file. And from there, everything is start to run. What we can also see here different from a VCL application is that we have, in connection with our form, also an additional HTML file. And this HTML file actually allows us to create a template, an HTML-based template for our form. So if you're not forced to stick with what you design on the form, you can lay out everything also via HTML. But let's start with the basics, and I will show you what we probably already did numerous times when discovering new frameworks. I drop a few components on the form, so that will be a web button, a web edit, and a web list box. Note that if you inspect the properties of our web button, you will find pretty much all the same properties as you also have for a VCL button or a FireMonkey button. We just wanted to make it as similar as possible to what you are used to in VCL and FireMonkey applications. The same applies, of course, to the edit and here the list box control. So when I will add some code here, and let's do it this way. I grab the value of the edit control, and I will add this value to the items of my list box this way. Okay, so very simple example. Now I run this application, so what's happening is that now the Past2JS transpiler is transpiling this Delphi code into JavaScript code, and that JavaScript code is launched via the HTML file. So you can see here that I launched the browser on this project HTML file, and my application is up and running in the browser. Noteworthy here is that what you see in the task bar area of Windows, that is that we started a small debug HTTP server. So that small debug server is responsible for serving the HTML file, the JavaScript file, and if other files would be needed to serve that to our browser. And you can see that this server is running on the localhost port, port 8000. As expected, of course, my list box is filled with the values that I have added in the edit box. When I now open the browser console and I go to sources, you can see that here is the structure of my project. So you can see project1.html, the file through which everything started, the JavaScript file, and here, interesting, you see the unit1.pas, which is the unit for my form, first main form. And you can see all the Pascal code that you added to your form. So what I can do now is set a breakpoint in the browser console on a line of Pascal code. And when I click the button, you can see that my breakpoint is hit, and I can now execute it line by line. The only annoyance is in the browser console that the shortcuts to step through your code are somewhat different from the shortcuts in the Delphi IDE. But you can see that here the variable S, I can inspect that in the browser console. So at Pascal level, I can inspect variables and step through the code. And so this gives you a way to debug your applications. If we want to have a small look at what actually is created, so what we would have to deploy to a server, let's save this to some folder. I will call this folder Salamanca, and let's save the project. Okay, let's compile again so that we can inspect the files that it generated for us. So what you see here is the TMS web folder, which is the output folder. There you find the debug folder, and here you actually find, in this case, 4 files. These 4 files are sufficient to deploy on your HTTP server to have this application accessible from everywhere. The map file is the file that is responsible for the debugging experience by debugging line by line in Pascal code. Obviously, this is typically not something that you will want to deploy to a released application, because everyone in that case will just see plainly your original Pascal code that might not be desirable in all circumstances. Other difference between debug and release mode is that in release mode, an extra optimizer is being run to reduce the size of your JavaScript file, eliminate unused code, and rename some, obfuscate some code. So that's what is the difference between debug mode and release mode. I mentioned that increasingly hardware has become easily accessible from web applications. And so let's have a small look at a demo that shows how you can use the camera. So here is a project, and you can see here I dropped the web camera component on the form, and here is a snippet of code that will actually perform taking a picture with that camera. When you see it in action, it will speak for itself. So here is my application running in the browser, and you can see it's me live through the webcam. And that's how easy it is to create web client applications that use a camera, and with a simple click I can take a snapshot and actually render that picture taken into a web image control. So it is being converted, in this case, to a web image control. Important to note here are a couple of things. I can use this camera here now because I'm running from localhost. Okay? You will not be able to use the camera when you deploy your web client application on an HTTP server. To use the camera in a web application, it is required that you run this from HTTPS. Okay? So that's a security requirement implemented meanwhile by all modern browsers for obvious reasons, that someone cannot spy on you by sending you to some URL and enabling that camera and spy on you. So first of all, the unique identification is what is happening via HTTPS. Secondly, when you run it this way, it will require, that's a browser implemented security level or issue, it will require an interaction with your web application. So you cannot, when you start your application, enable the camera purely in code. It will require that as a user you click on something to start it, so that to create that awareness that something is happening, that in this case the camera that you might be uncomfortable with privacy concerns that the camera is being used. So this was a quick introduction to the basics, web client applications. So now let's move to the next level, which is what I refer to as progressive web applications. So as I mentioned, these are web applications that can be installed on devices. By installing, I mean that all files for this web client application will be downloaded on the mobile device, on your desktop device. So the second time you run them, they will not be downloaded again. The browser actually is so smart, if it is online, to compare what it has downloaded with possible new versions that are online. So if you have a new version, it will get the new version, but otherwise it will just keep using what it has installed once. To make that application accessible from your mobile or desktop device, it will require an icon so that you can see, okay, this is the icon through which I start the application. So you will need to bundle icons with your application. And other than this, it requires a few other settings in files to make it to be recognized as a progressive web application, and as such make it installable from the browser. So this is an overview, a list of the requirements for your application for the browser to recognize it as a progressive web application. So it needs a service worker. A service worker is some separate JavaScript file that can run separately and also in a separate thread from your main web application. It will be cached, of course, to restart the application even if you're offline. It has a manifest file, which is a file which contains the settings for your application. It will include icons. Very important for being recognized as a progressive web application is that it implements responsive design. What I mean is that on any screen size, your application will look good. And so this is also a criteria. Also to be recognized as a progressive web application is that it will be run over HTTPS. So that's also a no-go when you want to deploy that over simple HTTP. And that application type is also available, accessible for WebCore. And there is a tool, Lighthouse called, with which you can test in advance whether your application meets all the criteria to be considered as a progressive web application. So let's have a look at how all that is accessible from, in this case, the Delphi IDE. And so I create a new application and I select here in the overview of applications an TMS Web progressive application. When I create this application in the IDE, what you can see here is that it already includes some extra files. It includes some versions of the icon, different resolutions for the icon that will be associated with your application. It includes the manifest file, which is a JSON file. We can have a look at the contents of that JSON file that is created to meet the requirements of the progressive web application. And finally, also in addition, there is this service worker JavaScript file. And this is the standard file that goes within a progressive web application. Mainly what you can see is that this contains the instructions for what files to cache so that your application can run offline. You can see here this $file list. When you compile your application, this list will be expanded into all files of which your application is created, and all this set of files will be cached and will make your application run offline. So let's test or have a look. I will add again some, just to see something. And let's just fill the edit control with Salamanca, for example, and run this in the browser. So, okay, you can see the expected behavior. And now let's have a look at what will be tested to see if this can be a progressive web application. Actually, if you pay attention, the browser already detected that this is a progressive web application. Everyone is seeing where the mouse is in the navigation bar of the browser. You see this extra icon of, it shows like a computer with a download icon. When I click it, it will offer or suggest me to install this application. Okay, so if I would click install, it will create an icon on the desktop, and from there my application will be accessible. So even without checking in the browser console, we already know that this is a progressive web application. But to perform the testing and actually see maybe where there is something wrong, there is in the browser console the Lighthouse tool integrated. And here you can see what it should test for, this Lighthouse tool. And automatically it is checked to check for a progressive web application. So now when I click Analyze, it goes through the process of checking all kinds of things. Even if you're not using or wanting to create a progressive web application, it's still a very interesting tool to use Lighthouse. Just for, I have here still a breakpoint I see. Okay, let's go to Lighthouse. And what you see here is that the progressive web application icon is colored green, which means that this is suitable or will be recognized as a progressive web application. And other than that, I think in here you can see the different criteria. You can see the different criteria that are met for being recognized as a progressive web application. This here is a remark, but is not critical to be detected as a progressive web application. It is some part of the manifest file. But the other things can be interesting as well for testing your web application. For example, here you see something about accessibility, which means how accessible is your application, for example, to blind users or to users with disabilities. That is basically hints that are within your application to guide the users to use your application. So also these things can be good to have a look at to see how your application is performing. Now, if you want to test it yourself, how such a progressive web application behaves on your device, we've also deployed such a progressive web application on this URL. So if you navigate with whatever device you have to www.tmssoftware.com/pwa/calculator.html, you will see this application on your device. You will have the opportunity to install that on your home screen and start it from your home screen. Also, here, this is a calculator application. You will be able to use that offline. If you switch your device to airplane mode, then it will still run the application. I see that a couple of you are starting this application. I see that, I'm not sure why. So, of course, I need to have an internet connection initially to run this application. And you see that the browser detected automatically that I now have an internet connection. And you can see this application in my browser. You can also see again this icon here that suggests that I can install it. And you can play with this calculator from your browser. Okay, sorry. I think I need to close my, now it's visible. Okay, here it is, thank you. So here you can see this progressive web application in the browser, installable here, the icon, and I have a fully functional calculator in my browser. You can also see here that I have a special font to show the numbers like an LCD screen. That will also be a resource part of your application that will get cached on your device when you install it. So also this will be usable when you are in an offline world. So this gave you a brief introduction of progressive web applications and how you can create them, test them from your browser. A last type of applications you can create with web technology are cross-platform desktop applications. And the first framework that enables you to do that is Electron. Electron is an open source framework. It was it originates from 2013. It was actually the framework that was created to build the Atom code editor. Atom code editor is actually the code editor that precedes Visual Studio Code. It was a code editor designed for being cross-platform. And it was actually developed by the owners of GitHub at that time with the idea for editing code on any operating system. And so Electron was the framework that they came up with to enable this cross-platform application development with web technology. And actually, Electron through the years got very popular, and a lot of applications were also cross-platform applications were created, built on top of the Electron framework. Here are a couple of examples. The WhatsApp client, Skype client, but also importantly, Visual Studio Code itself. It originates from Electron, but meanwhile Microsoft forked that Electron framework and created underlying its own variant. The other icon next to the Visual Studio Code icon is the Atom editor. The Slack client is also a client that was created with the Electron framework. So from TMS Web Core, we can also use that Electron framework to create cross-platform desktop applications. It's an application type that is integrated into the IDE you can select from, and then when you compile, it will generate a cross-platform desktop application for you. I wanted to show, though, in this presentation today, an alternative for Electron, which is Miletus. We created Miletus ourselves. It is very similar to Electron, with, to begin with, already one major difference, which is that Electron will always deploy a browser engine along with the application, while a Miletus application just uses the standard operating system browser that is available, which makes your deployment much lighter. We can compile applications as this for Windows, Mac, Linux, and Raspberry Pi, and actually we can compile or generate this type of applications all from the Delphi IDE on Windows. So from a Windows machine we can generate this way the executables for the Mac, for Linux, for Raspberry Pi. There is no strict need, although of course for testing highly recommended, but no strict need to have a other machine with the other operating systems to create these Miletus applications from. And of course, as it generates a desktop application, we will want desktop functionality, things like accessing operating system dialogues, operating system local file system, also local databases. So this all becomes accessible for this type of applications. Architecture is reusing or is similar to what you can do with WebCore Web Client. Still, it is based on Object Pascal. It runs in the browser engine, and as such, it means that we will compile Object Pascal to JavaScript, and it will run in a browser engine. As it runs in a browser engine, that means that you can take advantage of everything available in that browser, and foremost, this means all the tools you have to create nice user interfaces, HTML, CSS3. And here is an overview of the operating system browser that will be used for these different categories of targets for a Miletus application. When we compare Miletus versus Electron, here is a list of a few differences. or pros and cons of Miletus versus Electron. One of the pros of Miletus is that it supports Raspberry Pi. And the nice thing about supporting Raspberry Pi is that it can also take advantage of the electronics that you can connect to your Raspberry Pi. I'm not sure how many of you play from time to time with the Raspberry Pi or have applications running on a Raspberry Pi. So if you are into playing a little bit with hardware, I think this is a very nice platform because of the access you have with to other electronics things, I2C, SPI, the GPIO pins, and also the UART. And so we have made in Miletus these electronics access all possible from your application. The deployment of a Miletus application is very simple. It creates your executable and you just do Xcopy deployment. Here in this case you see the files, the project files for your Miletus application. You see the output, which is project 1, the executable, and the desktop link to start that executable. That's the only two files that you can deploy, Xcopy deployment, to your Raspberry Pi, and you are up and running. You can take advantage, as I mentioned, of the electronics. So this is an overview of the methods for working with I2C. So reading, writing to specific I2C addresses is possible, as you can see. The same applies for the SPI interfaces on your Raspberry Pi, where you can also do read and write transfers of data. You can manipulate each GPIO pin from your application, so you configure with GPIO config whether your pin is an input or output, for example, and then you can read, write values on these GPIO pins. And finally, the last one is the UART. That is also standard available in your Raspberry Pi, and so also here you can open this UART port and read, write data over UART. And so let's have a look at how this is all possible from your Delphi IDE. And let me open this project group. And first of all, I want to show you this application that shows you local file access and also using operating system dialogues for picking files. As you can see, the project structure is quite similar to a web client application. The only difference here is that we have 3 additional files, which are the icon files that go with your application. When you deploy it, this will be the icons that represent your application. Other than that, we have, in this case, the main form. And here in this main form, what do I have? I have a rich edit control, I have a toolbar, and I can open and save from the local file system. And this is with 2 non-visual components, the open dialog and the save dialog. So this will, from this application, trigger, it will be running in an embedded browser, but it will use the operating system open and save dialogs. It will actually also, with the Miletus main menu, it will use a real Windows menu on top. If you use the main menu on a Mac, this will be the main menu of your application that sits on top of your Mac screen. So it is the real menu of the operating system that is exposed here. Let's run this application to see what it does. Okay, so here is my application we have some basic toolbar here to manipulate the text. Hello world, live from Salamanca, for example. And here I can play with the font to make it more clear. Let's give this some other more visible color. Okay, so here we have some basic editor. And what I will do now is I will save this to some file, and let's call this salamanca.html. So now I accessed actually the local file system to drop that file on my file system. When I now clear this and open this again, and open this, salamanca.html file, you can see that our local file was opened just like you would do with an other desktop application. And here we have the same integrated in the menu. So as you can visually see, this is the operating system menu. Let's move now to a little bit more involved example, where we can access a local database via this Miletus application. And so what do I have? I have again an open dialog, the same as in the previous example. But here I have now introduced an Miletus SQLite driver, a web data source, and a client data set. So the SQLite driver component is responsible for accessing SQLite databases locally on my desktop. And it is connected to a client data set through which other controls can work with the data of this local database. And basically that is of course happening through the web data source that is collected to the web client, to the Miletus client data set. And here we have a dbgrid control. The dbgrid control uses the data source, and I have also a db image control, also connected to this data source and set to the data field picture. I have in a folder a SQLite database, and let me open that folder for you. Here is the folder, and here you can see it's actually here, I guess. I overlooked it. Okay, I think it will become clear where I had this file when I run this application. Let's see when it gets, I need to compile the DB access example and run it. And let's open the SQLite file. And here you can see the SQLite file, it's called delphibooks.db. When I open this file, you can see that it now opened the SQLite database, and I have here in my database different books and the description and information of these books. I have also a DB navigator, so that operates in the same way as you would do in a VCL database application. When I would edit here in the grid, I can change values. For example, let me have a look and put it in edit mode. No, I thought that I had enabled my grid for editing, but that's apparently not the case. But what I mean is that you could edit through this grid and you are actually working with editing this local SQLite database file. And of course, you can take advantage of everything that a browser offers to create a user interface with HTML, CSS, etc. And that gives you a brief introduction of what Miletus can do for you to create web client applications. With all these possibilities, I think that it's still a wonderful time to be an Object Pascal developer, and I'm open to some further questions from your side.